welcome to lesson number 4. And in lesson 4, we're talking a lot about radian measures in trigonometry. Last semester we discussed measuring angles in degrees. Now we're going to introduce the idea of radians. A circle is made using the vertex of an angle as its center. The measure of an angle can be given by the ratio of the length of the arc, so this S value, and we could find that in degrees. That was just the degrees divided by 360 times 2 pi r. And we know that we can use that S and divide it by the radius, and that will give us our angle in radians. So if measured this way, the angle theta is measured in radians, and if let's consider a semicircle, we see that we're going to take half of 2 pi r divided by that radius leaves me with pi. So we know that in radians, half of a circle is pi, so going around a whole circle is 2 pi. So 180 degrees is equal to pi radians. So on the bottom here, we're going to change some radians to degrees and some degrees to radians. To do that, we need to multiply by pi over 180, changes a degree to a radian measure. And typically, not always, you can have a radian without a pi in it, but oftentimes we leave it with pi in it. And 45 degrees would be pi over 4. Over here, where we have negative 60, if I multiply that by pi over 180, I get negative pi over 3. And down here, if multiplying by pi over 180 changes it from degrees to radians, if we do the reciprocal of that, 180 over pi, will go from radians to degrees. So I end up with 30 degrees there. And don't forget your degree symbol. And down here, doing the same activity, I get 180 over pi, and gives me negative 270 degrees. So if we recall from finding the area of a sector from before, from geometry, we would do the part of the circle times the area of the whole. Well, in radians, it's just the angle in radians divided by 2 times the radius squared, which is an easier formula. When studying rotating objects about a central axis, the angular speed, now this fancy Greek letter looks like a kind of a cursive W, is the amount of angle an object turns given time. Linear speed, or tangential speed, is the rate at which a point on the rotating object changes its distance at a given time. So what we have here is a couple gears. Let's take a look how we know the angular speed of the larger wheel that has a radius of 10 centimeters. So if I say is going at 100 RPMs. So if it's 100 RPMs, which is revolutions per minute, let me write it that way, revolutions per minute. And we want to change that. The first thing we have to do is change that into radians. And so we know that 1 revolution in radians is 2 pi radians. So if I change this from 1 revolution, doing the unit changing here, I get 2 pi radians. So I get 200 pi radians per minute is your angular speed for that. To find the linear speed, once we have it in radians, all we have to do is multiply that by its radius. So if I take 200 pi radians, and I just want to change it, multiply that by 10, I get 2,000 pi. But this time it's centimeters because we multiplied by the radius, centimeters per minute. And then the angular speed of the smaller one in radians per minute? Well, the angular speed is because that one is going to be turning the same speed, but it has to go faster. You notice that the belt on here has to be going the same speed, so we have to divide that 2,000 pi radians to find out by 6 because of the radius is smaller. So up here we had 200 pi radians for it. This one's going to be 333 1/3 pi radians per minute. So it's traveling faster because of the smallness of the pulley. The pulley has to go faster to keep up. And so then the angular speed of that one, and again, what we're doing there is we're going to change that back into revolutions per minute. So we're going to take, well, this is basically 1,000 pi over 3 radians per minute. And to get that, we have to get it back in revolutions. So I'm going to change it by taking 1 revolution is 2 pi radians. So I'm converting back. And so I get, looks like 500 thirds revolutions per minute. So we're just manipulating back and forth. On section 2 here, we're talking about the different functions. Recall that in measuring angles, the angle measure always begins at the initial side and ends at the terminal side. So the positive x-axis is going to be our initial side for almost everything, and the terminal side is where stuff ends up. Many times it's useful to place the angle on a Cartesian plane, the x and y axis in standard position with the vertex at the origin, and the initial side is along the positive x-axis. With this, it is possible to define the 6 ratios that are trigonometry. So, if we assume x or cosine is the x value, and I know this green line doesn't show up as well as I'd like it to, but that's a unit circle. They call it a unit circle because it's 1 unit from the origin, so it's radius 1. So, if the cosine is the x value, the sine is the y value, the tangent is the sine divided by cosine, secant and cosecants are reciprocals of cosine and sine, and you can see the 1 over x and 1 over y, and the cotangent is the reciprocal of tangent. If on the circle radius of radius r, replace x by x divided by r, I get these values. If it's not on a unit circle and it's not 1 long, then we have to adjust those values. All right, so now let's talk about finding some of these values. So I'm going to put my unit circle over here. And if I'm going to find all the trig ratios at pi over 2, well, we said that there's 0, this is pi, so pi over 2 is at what we would normally call 90 degrees, but we're in radians now, so we don't call it that. We call it pi over 2. So we're going to find the sine of pi over 2, and we know that the sine is the y value up here. So if I put a y value up here, this is the point 0, 1, so my y value is 1. Cosine at pi over 2 is 0, that's the x value. The tangent at pi over 2 is equal to sine divided by cosine, so 1 divided by 0 dividing by 0 is undefined. The cotangent is 0 because that's the cosine divided by the sine, so 0 divided by 1 is 0. And then the secant of pi over 2 is going to be the reciprocal of cosine, and the reciprocal of 0 is undefined again. And if I do my cosecant at pi over 2, that's the reciprocal of 1 and 1. That gives me 1. So we're going to do the same thing over here at pi, because pi, the negative pi, means I'm going this way around. Or if I go this way around, they are called coterminal angles, and they end up being at the same point. Well, this point out here is my x value is -1, my y value is 0. So I know that my sine, let's get a different color pen here, my sine at -pi, which is the same as pi, the sine there is going to be equal to 0, because the sine is the y, the cosine is the x. The tangent is the sine divided by cosine, which is 0. The cotangent is -1 divided by 0, which is undefined. So in relative terms here, we know the reciprocal of 0 is undefined, and the undefined is 0, which is going to become important. The secant is -1, reciprocal of -1 is 1, and again, the cosecant up here is going to be my undefined. Now, if we get to our last point here, which is -7 pi over 2. Now remember, negative, we're going this way, which is clockwise around it, instead of counterclockwise. If I go all the way around here, that's 2 pi, and we can write that as 4 pi over 2, right? And so then I'm going to go another 3 pi over 2, so I'm going to end up here. So a coterminal angle with that would be pi over 2. And we already know the 6 ratios over there that we did for pi over 2. All right, so now, remember earlier I said you can have a radian measure that's not in terms of pi. And so here's an example of that. I'm going to, I know that this value is going to be 3.14159.265, blah, 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 right? And this will be half of that, about 1.6 something or another. And down here is 3 pi over 2, which, whatever that ends up being. And this back here, it's either 0 or 6.28. So we're going to call it, well, it's 9, so 4 point something down there. All right, maybe high 4s there. And so if I do the cosine, which is the x value at 4, well, it's going to be before this 4 point something, so it's going to be down here. So my x values are all negative. The sine at 2, the sine is the y value, so somewhere between here, the sine is, since the y values are all above the x-axis, we know these are positive. And the tangent at 6, so down here, we know that the y values are negative, the x values are positive. So we know that the tangent is a positive divided by, or a negative divided by positive. So I get a, down here the tangent would have to be negative. All right. Suppose that P is a point on the terminal side of an angle in standard position that meets on the unit circle with a y value of -3/5. So what we can do is draw a triangle there. Since we know it's on a unit circle, we know that distance is 1. And we can say that -3/5 squared plus b squared equals 1 squared. And so I get 9/25 plus b squared equals 1. B squared equals 16/25 square root, and I get plus or minus 4/5. Now, a lot of times in geometry, we would throw away those negative values, but let's look at what x value, if we're going this way, my x value to the left of the origin on my would have to be -4/5. My y value is -3/5. So that's what we were looking for there. All right, I think we are done with the first 2 sections.